So welcome all. Thank you so much. First of all, I just would like to give a word of thanks to Russell, Daniel, and Yazan before everybody else, because they really, have done most of the work, and in fact, all the work on in terms of the flyers, in terms of sending out the invites, trying to even get the right list of people, and hopefully, this is the first time we are doing this. The main idea I had, being a faculty in electrical engineering, is that we wanted the seniors to kind of tell the students, and hopefully we will have another version of this in the later part of the semester, where we'll get some EE and EE related field alums who can give their perspective. But the idea was that to kind of inspire and excite the sophomores and the freshman students about this field, right? What made some you guys follow, choose electrical engineering? What did you find exciting? And hopefully some of that will trickle down to the freshmen and the sophomores, and hopefully they'll find an interesting pathway for themselves. So I'm not going to take a lot of time. Just I want to thank, first of all, the team I have, Russell, Daniel, and Azan, and a big thanks to Daniel, both the Daniels here, Tanya, Taylor, as well as Will, for actually accepting our invitation and for doing this. And hopefully this is the first version, and if we do it again, maybe we can actually, bring in some of you when you have joined your own respective companies or research labs, etc., to give us that alum version of it. But anyway, without any further ado, I just want to give the floor to Daniel Gruber here, who will be kind of going through the next phase of this seminar. So welcome all. Hopefully you enjoy. I'm looking forward to a good, very live and interactive Q&A and a live and interactive panel discussion.
Thank you, Professor Panda. So first, of course, thank you panelists for being here with us today. We're really excited to hear from you. I guess first, maybe we could all go around and introduce yourselves, say what you're studying, what you're interested in. Yeah.
Sure. So, hey everyone, my name is Daniel Esguerra. I'm a senior from California studying electrical engineering, computer science, ECS. My work focuses primarily on FPGA security, and I'm excited to join NASA at JPL this summer.
Hi everyone, I'm Will Doyle. I'm a senior from Massachusetts. I'm doing the ABAT electrical engineering degree here. I'm not part of a lab, but I do work in the undergrad teaching labs, helping to prepare exercises for all of you when you take your 200 level EE classes. And I'm also a ULA for Professor Panda's 201 class. And when I graduate, I'm going to be moving to Austin, Texas to work for BAE Systems.
Hi everyone, my name is Daniel Bakeski. I'm a senior student in electrical engineering on the ABET track. I'm actually from Houston, Texas. So Will, you're welcome in Austin. My interests currently are at the intersection between humanitarian crises and energy and healthcare. So I'm looking to bring an engineering aspect to that. Upon graduation in the fall, I'll actually be starting a master's in business administration at Yale SOM.
Hi everyone, my name is Tanya Jamra. I am a junior studying electrical engineering and economics, also from California. This summer, I will be working at Morgan Stanley in investment banking in the tech group. But it's not really a long-term interest of mine. My long-term interests are more focused on sustainable energy in back home, which for me is Lebanon. So yeah.
Hi, I'm Taylor. I'm a senior from Myrtle Beach, South Carolina, and I'm studying electrical engineering ABET and also doing the energy studies certificate. So there's a lot of us here interested in energy. So I've had internships at utility companies, which is where I hope to work later on in my life. But after graduation, I'll be doing consulting for utility companies and independent power producers.
Great. Thank you so much for those wonderful introductions. So the first formal question we have for all of you is, looking back, what made you pursue EE or EECS, and what made you stick to that path? And if you could maybe give us a little bit of an idea of some of your current activities on campus and your trajectory over the years.
I guess I can start unless you want someone in particular to go. But so I kind of always knew coming to Yale that I wanted to do engineering, but my interest kind of varied over the years. And I got into astronomy and I got into physics and I was interested in economics for a while, but kind of the whole constant thing through that was electrical engineering. I knew I wanted to do something with engineering, mostly because I know I like solving problems and trying to fix things and see a problem and fix it and make something better. I've always enjoyed that. I think the cool thing about doing that at Yale is, I mean, we all go here, we know that engineering isn't Yale's biggest department, but that also means, we still have access to the same level of, top level Yale resources. We just have to share them with fewer people. So, as a whole, we kind of get more pieces of the pie compared to the bigger majors, which I think is great. I've never had any trouble talking to a professor I wanted to talk to, or like, hey, can I do this project? Oh yeah, the department will give me $1,000 to do it. That's nice, and you can't really get that in every other department, which is great. In terms of things I've done around campus, like I said, I work in the undergrad labs. I've designed a few boards for EE 201 and 203. And I also run a high school first robotics team here in New Haven, which again, because in EE you kind of get to know everyone pretty quickly. The department's given a lot of monetary support for that. So that's one of the things that really surprised me most is the department will support you in whatever you're trying to do, which is nice. If you have an idea or a project you're working on, you're going to find someone who can either give you advice or money. We all know how important that is. So yeah, that's kind of what my trajectory has been over 4 years, but I'm sure someone else on the panel can share what it's been like for them.
Thank you. Does anybody else want to offer their thoughts?
I suppose I could speak a little bit to my own experiences. Similar to Will, when I came into Yale, I knew that I wanted to do engineering. I diverged a little bit from Will in that I knew exactly I wanted to do electrical engineering. I absolutely loved circuitry, loved E&M in high school. It was just really just a passion of mine. And I remember to this day taking my very first EE class freshman year, and I thought, wow, this is incredible. I'm going to be able to design all sorts of circuits, going to be able to make my own gizmos, my own gadgets. This is going to be very fun. And fast forward 5 years later, I was originally class of 21, and it's come true. Like, I'm now designing my own PCBs. I'm really investing in my own electrical skills, working with engineering and all of that. And truly, Yale EE has empowered me to be able to reach and develop my own things, which has always been a long-standing dream of mine. One thing that really attracted me beyond just the core science of EE is actually the mentality that EE instills you with. I think that the other panelists can probably agree in that EE is a fairly unique engineering discipline when compared to the others, and that we have this thing we call like a black box approach. And it's this idea that you don't have to understand every little detail of the system. You just have to understand how well it responds to inputs and what are the kinds of outputs you get. And that really is a type of, if you acquire that type of mindset early on in life, that can really empower you, whether or not you go into aerospace, investment banking, or any energy, utilities, like Taylor, anywhere really, that can be a very useful mentality. It allows you to generalize and work with very complex systems. So that's really a big plus.
Thank you, Daniel. Any of the other panelists?
I can,
Oh yeah, Tanya, go ahead.
Yeah, so my reason for pursuing EE to begin with is kind of stupid, but like, it's just like I solved, like, in high school when you're doing, physics and whatever, and you get to the circuits part, it kind of just felt like I was like doing a crossword puzzle, if that makes sense. That like little like feeling of joy that you get from solving like the Wordle of the day or whatever. So I was like, okay, I'll pursue this for 4 years of my life. So that's what like sparked my interest initially. I came to Yale, I started taking the classes, I realized I liked them. But I really resonate with what Daniel was just talking about. I think a lot of us on this call probably do. 95% of the time, I have no idea what's going on. And like electrical engineering has taught me that that's okay. So I think it's actually like a really useful skill to have developed skill, if you could call it that. And currently, so like at Yale, I did research. I didn't really like it. I've been involved in IEEE, which like I know a few other people here have too. And I really loved it. We worked with a local high school and helped them build like solar powered mini cars. And so we got to go and teach them all of these different concepts about energy. And it was really cool to like show younger students the things that got me interested in electrical engineering to begin with. I'm also involved in, this is like non-EE related, but the Yale Student Investment Group. This is kind of more on the economic side of my like career, I guess you could say. But within that, I was in the technology group. And so I've even found like applying to all of these jobs and working in investment banking this summer in technology, that electrical engineering is really helpful because you kind of have an idea of what all the actual products that you're investing in are, or like that your brokering deals are. So yeah.
Awesome. Okay. Yes, Taylor, go ahead.
So apologies if I like break in and out, but I'm using an old computer, so it might not be processing super well. But when I originally applied to Yale, I actually applied as a CS major. And I didn't even take my first CS class at Yale until my senior year. So I definitely did a little bit of a 180 there. But when I was in high school, I was fortunate enough to be able to take a power engineering class, and that kind of really struck my interest. When I came to Yale, I actually found that Yale didn't have any power engineering classes, which is kind of frankly a shortcoming for myself. Even if you can't find the exact niche that you want to do at Yale, there's so many opportunities for you to do that in other areas, which is why I was willing to stick in EE, even though it wasn't the perfect fit for me. I was able to join student groups like YIEEE. That was very important to me. I got to study abroad and take classes in power engineering. And even though sometimes the EE classes at Yale were pretty difficult for me, and sometimes I was like, I don't even want to like do semiconductors after graduation. A big part of doing the curriculum here is just kind of learning how to be an engineer. So even though it wasn't the perfect fit for me, I still was willing to stick with EE ABET because I knew in the long run it would equip me to do kind of anything that I wanted to do.
Great. Okay, I think that those are some great final words to end on to go into our next question. I was wondering if any of you could speak about some like interesting projects that you've worked on. Feel free to get into as nitty-gritty as you want to. You know, we just want to hear if there's anything that you're passionate about, anything that you're proud of that you've like accomplished over your time here at Yale.
I can lead with this one again. So I've, you know, like I said earlier, I've kind of bounced around between interests. You know, one semester I'll be excited about robots, and then I'll be interested in batteries. And kind of one thing is, speaking of batteries, is I was able to do an independent research. So, you know, this counted for credit in the EE department. And I basically walked up to the EEDUS at the time and said, hey, I want to, you know, learn more about batteries. Can I basically use your lab and teach myself how to use a glove box and play with dangerous chemicals all semester? And he was like, oh, sure, just write a prospectus and that's fine. And, you know, the department bought all these crazy chemicals with names I can't remember. And I, you know, read some textbooks, read some papers, and in the end, I just built my own batteries, which essentially were, you know, I'll spare you the gory details, but, you know, we have a battery problem. We all know, you know, we all like Tesla and everything, but those batteries can only get you so far. So we need better ones. And I was able to work on batteries that worked with basically aluminum metal and then reacted with oxygen. So because there's only one metal, you can condense them. And it was, you know, it was just a fun project and something that, you know, again, at a lot of places, you wouldn't be able to just walk into a lab with no experience and have a run of the place and do it on, you know, the university's dime. And then last semester, I was really interested in kind of weather balloons and stuff like that. So again, same thing, walked up to the DUS and said, hey, can I do this project? And, you know, $1,000 later, I was able to launch something up in the sky, chase it down, and, you know, go through the whole design process, order everything. And, you know, there's just a lot of support from the department to do those sorts of things. So that's been my experience, and it's just really nice.
Thank you. Any of the other panelists?
Sure, I can talk a little bit about my experience. So my first year when I took E201 was my first exposure to FPGAs, and then I really enjoyed working on that programmable hardware. And so I actually ended up helping out in the computer architecture and security lab with Professor Zephyr, and I've done it now for the last 2 years. Obviously, once you're in a lab, you get a lot more exposure than you would in the classroom, and you get to learn a little bit more of like the academic research process, which is really nice. It also was really good experience for like internship opportunities as well, especially if you want to apply certain research aspects to industry. My first 2 years, I was working on ground control stations for military Group 3 UAVs. And so we were specifically working on the interfaces for the pilots that were on the ground that communicated up to the planes flying in the air. And then with what I was able to learn in the lab, I was able to apply it to the FPGA work that's going on at NASA right now. So I don't know if you guys are familiar with like the Perseverance rover on Mars right now, but it has 6 FPGAs on board, and the small little Mars helicopter that went along with it also has an FPGA on board. And they are an essential part of the brains and the flight electronics in that. And it was really cool to get to help out over the summer there with what I learned in the lab here at Yale. And the stuff we were working on on this past summer at NASA was for the next Mars mission, the Mars sample return mission, to try to get the samples back from Mars. But all of that started with the initial exposure that I got in 201, where we just tried to put some circuits to turn on some LEDs in like an introductory class where they gave us these FPGAs and a little bit of exposure to Verilog. But just with that, I've been able to like launch forward and get to do really, really cool things because of that initial exposure.
Thank you. Anybody else want to speak on their experiences?
I can speak a little bit on mine. So during my junior year, I had the opportunity to get started in a research lab. I've been with the group for roughly 3 years now, and it's an electrical engineering lab. However, we work with biosensors, and that is something that I never had really considered to be a potential career path for me. And so I remember to this day, walked into the lab thinking, okay, what circuit am I going to build, right? And then suddenly we learned, okay, so you're not just going to be building a circuit, you're going to be interfacing it with cells and blood and all of these different saline solutions. You're going to have to work with pumps. All of a sudden, you know, I was exposed to this completely different world that I had never really thought of before. And with the support of the department and the professor and my peers, you know, I was able to learn a great deal as a result. And eventually we actually designed a small system for counting cells. Now that, you know, was just an absolutely incredible experience. I've learned a great deal, and it's actually sparked my interest in the healthcare industry and in nanodiagnostics. And all of that was done using just at its core and essence, the fundamental principles taught within the Yale classroom, within the electrical engineering classes. And, you know, learning about capacitances, learning about impedances, how do you design a voltage divider circuit, which is relatively introductory, but is still actually very, very widely used in industry for these types of sensors. So just having the opportunity to take what I learned in the classroom, apply it towards a field that going in, I knew very little about, and then being able to say, we actually did it. We got it done, we made it, and I've learned a great deal as a result. That was an absolutely remarkable experience. Now moving on to the next thing, which is actually you could say an implantable neural probe. So then again, something completely new, working with the brain. I went from cell counting to now, oh my God, we're putting something in people's heads. But it's all quite exciting in the world of EE here at Yale. Research can be fun, so keep that in mind.
Wow, these definitely sound like a lot of very, very interesting projects. Anybody want to add to that?
On the note of research can be fun, it's also okay if research isn't your interest. So I tried research my first year. I was working in Professor Han's lab on these blue lasers, basically. It was super, super interesting. I had so much fun, and I'm so appreciative of the community that I built there, but I realized that research wasn't really for me. I prefer doing like smaller projects. I'm also not a super hands-on engineer necessarily. So maybe that's also kind of where that disconnect was. But I guess some other projects that I did is I took wireless technologies with Wenjin Hu, and I kind of forced my interest onto that class in the final project, where we had to design some sort of wireless like final project. And I built like this solar tracker that reported how much power it was producing, and like displayed it or transmitted the information wirelessly and then displayed it like on a website. And then another project I did is that I took a School of Management class in Business and the Environment. Or that's not true. I did take that. This was in a different class. Sorry, I took a School of the Environment class in Utilities Business, and we had to have a final project where I suggested we designed what's called a solar canopy over like a water canal. So as part of that project, we had to kind of design like the wattage, how much power produced, figure out how much power it would conserve in comparison to a traditional solar installation. So I've kind of had a little bit more untraditional projects. I haven't taken on a very large project or haven't really done research, but there are still other ways you can find your interests and maybe in places that you didn't really expect it.
Thank you, Taylor. Okay. Any last words before we move on? Okay. In that case, Russell, do you want to introduce the next segment of the panel?
Yeah. Thank you, everybody, for all of your really thoughtful answers. We're now going to be moving into questions about like practical experiences. So the first question that we wanted to ask everybody was, did you have any summer internships or other experiences that were especially impactful for you, and how did you find them?
I can go again. Sorry, I know I just spoke. So my first year summer, I did STARS, which is a research program for underrepresented students in STEM, which I highly recommend if you're a first year or if you're a sophomore. It's a really wonderful program. It's very encouraging. It kind of sets you up to succeed in research and, learn the tactics to do well in it and how to make connections in academic circles. So after I speak, I'll put a link in the chat for that. But that's during that research program, that's when I worked in Professor Han's lab working on the lasers. And then unfortunately the pandemic happened, so I kind of lost a summer or two, or just one summer. And then this most recent summer, I worked at Avangrid, which is a utility based in the Northeast, on their smart grids innovation and planning team. And I actually found that opportunity through the Yale Career Fair and through Yale Simplicity. And I just reached out to the on-campus recruiter, and she was really welcoming and very helpful. So I can also put in links for helpful places to find contacts for recruiters. So yes, I will follow up.
So thank you, Taylor.
I can go next. So like Taylor, I did research, was really appreciative for the opportunity. I really liked the people I was working with. It just like wasn't really for me. But I did find something that I liked within it. And it was actually in high school, it wasn't in college. I did research at Stanford in a material science lab working with batteries. And the reason why I liked it so much was because the PI in this particular group was really like placed this huge emphasis on always like taking a step back and looking at the bigger picture of things, because I find like the higher that I go in like electrical engineering classes and just like classes in general, you end up getting in the nitty gritty and then you kind of like go crazy because you're like, I don't know what I'm talking about. I don't know what the applications of this is. Like, what does this matrix represent? I'm like, I don't understand anything that's going on. And so I found that experience really valuable. And it kind of taught me that skill of like, you always need to take a step back and look at the bigger picture, because like at the end of the day, what's going to get you out of bed in 40 years to go to your job? Not that I know I'm not 40, but like I would assume like it's not going to be like the little math and whatever, all the intricate little parts of things. It's going to be like, how are you actually helping people with the projects that you do? And so I think that was sort of what drew me toward technology finance. Was like, it was like a lot of big moving parts that I was looking at instead of like the really specific things. And then the summer of my freshman year, I worked at an asset management firm called Hotchkiss and Wiley, also in the technology group. And yeah, so.
Thank you, Tanya.
Maybe the boys can take a jab at this question.
Sure.
Daniel and Will.
Yeah. I mean, I think I already touched a little bit on some of my internship experience. I think the one thing that Tanya mentioned that I think is kind of important is that the little intricacies, like even though to some people it might seem really interesting to learn like the actual details of how electrical engineering and like electrical components work. I know that there's also some friends that I had that don't necessarily had found that super interesting, and it wasn't until they did an internship where it actually had like a much broader application that they were able to actually find the fun in it. So for example, like I mentioned, I was helping out with the ground control stations for those UAVs. And even though like the actual, let's say, for example, if you took a class where you learn like the syntax necessary to program, it might not necessarily be the most fun thing. But once you learn the syntax itself in the classroom and then get to apply it to something really cool, suddenly you're making your own graphics, you're helping out with a certain bigger project in mind, and it can become a lot more fun. And then after I did the UAVs for the Special Operations Command, I then started helping out at NASA. Oh, by the way, I guess I should mention that the way I was able to find these internships, which I think is helpful, is the first one I found just by asking friends that knew about available positions. And that was one way. And then the NASA one I got through the Society of Hispanic Professional Engineers here at Yale. There's various groups on campus that can easily get you in touch with companies, especially companies that are very interested in recruiting at the moment. Sometimes companies will even reach out to groups on campus to have events or something to do with recruiting that can be really advantageous, because that way they want you just as much as you want to help them. And then that's how I was able to get on board at the Jet Propulsion Lab at NASA, and then help out with the FPGA projects for the Mars sample return mission there. But yeah, definitely something to keep in mind is that even if the introductory classes are not necessarily like the most interesting, there are those basics that you eventually have to learn, and it's those basics that will allow you to do like the really, really cool projects later on.
Yeah, I can take a chance here too. So I've been kind of lucky. I've had a bunch of different opportunities over the years. Kind of starting in high school, I worked for a few robotics companies, and then I also did research, and I also found it wasn't for me. So I guess I can join that club. And then I've had a chance to work for a satellite company and then a defense company, and I think kind of none of them specifically were incredibly formative. Like, I tried research, it wasn't for me at that time, but maybe I'll try it again in the future. I think what I would advise you to do is try and get as diverse a number of opportunities or internships as you can, because like what served me the best wasn't like the technical things I did at one spot or another, but being able to have worked at a 40,000 employee company and a 4-person company, and to see what that's like on both ends. And being able to work in slightly different areas of electrical engineering. A little consumer robot has much different requirements than a jet. And that's the piece of advice I'd give. And I mean, obviously, so I interned for this company, BAE Systems, last summer, remote, and I liked it, and I applied, and that's where I'm going now. So certainly, any of these places you intern at in college can end up being a place for you to land after you graduate. Because I think from their point of view, they know you, they know what sort of work you do. That's an easy hiring decision. So that's been my experience, and that's my advice.
Thank you. Awesome. Okay, so as a follow-up to that question, we were also wondering if there were any specific courses, either at Yale or online or on other platforms, or personal projects that helped you with your internship experience.
I think I just want to add one more like extension to that, because not most of you have done internships, or even like, some of you have done research. Just wanted to like, if you can give your perspective on, because you are learning at Yale, it's a liberal arts school. So, how did this Yale shaped engineering curriculum help you find your internships, or like, did that help in some different way, so this liberal arts education having like more limited engineering courses, for example, did you go and look into some online classes, or actually like some of you actually went for, I heard, have done interesting internships in some tech firms and some fintech firms, financial tech firms. So if you all of you can give us a perspective on that, that would really help the students here to kind of get an idea about what would be some interesting pathway for them in the future.
Sure. I think for me, I mentioned my exposure to FPGAs in my first electrical engineering class, which was Electrical Engineering 201, which is an introduction to computer engineering. And just having that little bit of exposure, I think, was very good, because I don't think many college kids have that much experience with FPGAs, especially if they're just in their bachelor's at the time. So I think that was a really big help into being able to get involved with FPGAs at NASA. But I would say that since we are at a liberal arts college, there is an opportunity to, even though there is a limited course selection, there is an opportunity to take courses that might be a little bit more, not necessarily just focused on the engineering aspect, but maybe focused on other aspects as well. And so, for example, this doesn't necessarily pertain to my internship experience, but I've had a lot of fun taking classes in computer music. So I've actually taken 3 classes that all were involved with programming and music, which has been really fun. I'm sure maybe other panelists can talk about how they've done the same with maybe like energy or environmental studies or anything like that. Those are also definitely advantages. I think that not all employers, but there are definitely like institutions or employers or universities that may value the idea of having a liberal arts education, because you likely are expected to have a much more well-rounded education, where it's not just technical skills that you learn, but also things that have to do with like communication and writing and proposing ideas and things like that. And I think those are definitely things you always have the opportunity to emphasize when you're putting yourself out there as a candidate for a position that you're looking forward to.
Awesome. Thank you so much. Anybody else have a perspective on this? Yeah, Tanya.
Yeah, I think what I found is that when you come into an internship, it doesn't really matter what the internship is. It doesn't matter if it's relevant to what you study or not. most of what you do on the job, you will learn on the job anyway. So like it doesn't matter like where you went to school. And I also think that like, it's like, what am I trying to say? Like, it's really cool to be able to take classes that aren't strictly in electrical engineering, because there's no such thing as having a job that is strictly electrical engineering. Like your job is always going to be, or whatever you do in life is always going to be electrical engineering plus something. Like it's not a vacuum, right? Like you don't do this just because you think the wires look pretty or whatever it is. There's always like an application. So I am taking a class right now in the School of Management and the School of the Environment called Renewable Energy Project Finance, where we model out like all of the finances of different like big renewable energy projects and wind energy and solar energy. And that's been really cool. And so I've really like appreciated that aspect of it. And not even just that, I mean, I've also like had the opportunity, like I said, like long-term, I want to be working like in Lebanon or just like the Middle East in general. I'm Lebanese. And so I've had the opportunity at Yale to take Arabic classes and like make my Arabic, you know what I mean? Like that's something that I can tell employers, look, I have like a certificate in Arabic from Yale University, you know, like that's pretty valuable too, I think.
Thank you, Tanya. Yeah, Daniel.
Yeah, actually, I'm going to second a lot of what Tanya and Daniel have just said. Truly, I could not endorse this enough. Make your time at Yale very, very diverse in terms of courses. Like that is absolutely fundamental. Thinking back to my internships, just like Tanya said, you know, it's not just electrical engineering. So I had one opportunity to work with General Electric Renewable Energy. And while I was there, I was helping them essentially quantify the auxiliary power demands for one of their wind turbine models, and then actually make a recommendation for what size transformer they should actually put next to the model for the appropriate power conversion and power supply to all auxiliary subsystems. And you know, in order to do that, I had to know first off how to ask questions, how to really interact with other people, with my fellow peers, with my colleagues, to understand where they were coming from. What was their perspective of things? How could I present my questions most clearly? How could I present my ideas and my arguments most clearly? And one class that had a huge impact here is actually a class I took, I think, sophomore year, Problems of Philosophy. This was a philosophy course where all you did was you dissected the various paradoxes, you know, the quintessential issues within philosophy. And you had to understand what were their underpinning axioms, what were their premises, how does one thing flow to the next, and then eventually how do you arrive at the conclusion. And through studying that, you learn how to do that yourself. And that is absolutely paramount when you're in, for example, a board meeting and you're trying to tell people, okay, I think that this is the best course of action, and here's why. I don't think that we should do this, and here's why. Like, all of that is absolutely critical. Again, also, going to endorse the foreign language departments here at Yale too. I plan on working eventually in South Asia, so I've had the opportunity to study Hindi. I started, and I'm going to complete a certificate in the language here at Yale. And again, that is also very, very unique to Yale. I think that you can have such a rigorous engineering curriculum along with pursuing philosophy and languages. I took a course in renewable energy, and that actually helped prepare me for working with wind turbines as well. So really, it is what you make of it, and you can explore all sorts of avenues across all spheres, and it's absolutely incredible. So highly recommend that.
Yeah, Will.
Yeah, I agree with what everyone said about, taking a diverse course set, and like Professor Panda said, we don't have as many electives here on the engineering side, and so we make up for that with our distributional requirements, and that certainly makes us look different when companies are hiring compared to your standard engineering grad from any normal engineering school. But the thing I want to mention is I think Yale does a really good job running its, with all of the clubs that are available. I mean, I know every college, every university has clubs, but I think it's kind of rare to have the resources that Yale throws at us and lets us do. I mean, I know Tanya said she does some work with the student investment group, and I don't know, do you think you guys have over $1 million in assets that you guys just manage? And like, that's not something you can get everywhere. And I'll let her tell her stories, but for me, I work with this robotics team in New Haven, and Yale has been incredibly supportive of that. They've the seed has helped manufacture parts. They've helped, people have helped me write grants. Yale has provided resources. Oh, okay, 500,000 is close enough. And kind of what that's done for me is just given me a lot of leadership experience, which, I think the two things that companies are looking for is, do you know your stuff and do you have a wide range of, courses you've taken, which people have talked about already, but also what leadership experience do you have? And I think the ability to manage Yale level resources and manage Yale level clubs is something that not a lot of other people have, not a lot of other people our age have a chance to do. And that's a good experience for you. And it also makes you look good, when you're applying for jobs.
Awesome. Well, thank you everybody for sharing your practical experiences and also.
I thought Taylor was unmuting herself, so I don't know if Taylor had something to say.
Yeah, I'll just say real quickly. I agree with everybody about getting a diverse set of experiences, and again, just finding your niche and like just kind of making opportunities for yourself. Many of us here have taken school of management or graduate school classes that aren't in the engineering department, and I think that's really valuable. Like when I was applying to engineering positions, they really appreciated that I had kind of this business background. And when I was applying to business positions, they really appreciated that I had the engineering background. And I feel like that's really special to Yale, that the liberal arts education prepares you in so many different ways. And they really, when you're applying to jobs, they want well-rounded engineers or whatever you're doing. And then also like studying abroad was really important to me. I was able to demonstrate that I could go to another country and do research and take classes. And also the energy studies certificate has been very helpful for me because it shows kind of a demonstrated interest in my area. So even though at Yale I haven't been able to take engineering classes in energy, I'm doing energy studies, and I feel like that kind of makes up for it. I have the engineering background. I may not have the power engineering background, but this certificate complements it and shows that I have some knowledge about the field in general. So yes, anyways, get a diverse set of experiences and take advantage of everything that Yale has to offer, because it can offer you so much.
Thank you so much, Taylor. I apologize for accidentally skipping over you. Now we're going to hand it over to Yazan to talk about academics and future plans.
Thank you, Russell. Thank you, Danielle, and thank you everyone for coming here. I feel like the last question was a great segue into academics. And I feel like one of the biggest questions that every prospective electrical engineer at Yale asks themselves is EE or EECS. I was wondering if you guys can, say how you made up your decision and how the major has been so far in terms of commitment, course load, etc.
I can start on this one. So I am a proud EE ABET major. I know CS is very in vogue right now, as we all know, but I've stuck with EE. And the reason I did that is actually when I was graduating, I was talking with, some engineers I knew in the field, and they were giving me their advice on college. And everyone seemed to be telling me that every RF engineer or every electrical engineer that they knew was 55 and thinking about retiring. And it just seemed like there was, and okay, that sounds kind of depressing. Do you really want those people to be your coworkers? Well, and nothing against them, but like, oh, it's not a young, sexy field. That's not great. But what that also means is we're not going to stop needing electrical engineers anytime soon. And if they're all retiring, that is going to put the value of the major up, right? If you want to think of it in economic terms. Like we all know how important CS is. And if you study CS, you're never going to lack for a job. But it just seems like I was really excited about electrical engineering because not as many other people seem to be. And it seemed like there was a gap between the need and what people are actually doing. And that can be really where I provide value in the world. I mean, so that's why I like EE, and I've enjoyed it so far. I think the Yale courses have done a pretty good job preparing me. I won't say it's easy because it's not, but the best thing about it is it's a pretty small, tight-knit group of us who are all, EE, even EECS people, we're friends with each other. We all get along, we know each other, and we help each other on homework, and we get through it together. And that's really made it doable over the past few years. But that's my take on EE versus EECS.
I'd be happy to defend the other side. So I'm also a proud EECS major, and I guess one thing is when I was a kid, I was really into video games. And so a lot of people like putting together their own computers so that they could play these really good video games. I was fortunate enough to do so in middle school and then upgraded in high school, but I never actually knew how the components on the computer worked. So my motivation was that I wanted to learn how the computers worked. And that's what I got into electrical engineering, specifically in terms of like computer engineering. So I did come in with an interest specifically in computers, and most people that probably have an interest in computers are probably going to lean more towards computer science rather than electrical engineering as a whole. But I think what's really valuable about doing EECS versus CS, let's say, is because you actually get to learn about the hardware and how that actually works. And then, of course, like having the knowledge of CS with EE allows you to work specifically more on computers. I think that there's definitely going to be advantages to both options. And if you go for EE, you'll definitely get a much more in-depth view of electrical engineering. Plus, you'll also get to the chance to probably take more electives, also because it's required of the ABET major in the first place. But then EECS is definitely going to be really valuable for people that want to go specifically maybe into digital systems or computer engineering or things that are much less analog, I guess you could say. I mean, it definitely depends on the interest, but since my interests lie more with computers and FPGAs, I'm definitely going to be much more biased towards the EECS.
Great, thank you so much. Tanya, you can go.
Yeah, I talked a little bit already about why I decided to pursue EE in the first place, but I'm also an econ major. And I think really my incentive for that was I really want to like work with people or do something related to people in general. And I felt like you're at Yale, and we already talked about it's this liberal arts school that has all of these different departments and all of these resources. And I really wanted to take advantage of that and kind of like spread myself out. But I suck at reading and writing. I basically read at like a third grade level. So econ was like the closest thing to people that involved the most amount of math, if that makes sense. And I started taking classes and I really, really liked it. It was like people and numbers, no words involved. I haven't had to write a single paper. It's been beautiful. And so, yeah, that's my take on why I'm an econ major, which I know that wasn't the question, but there you go.
All good. So for ABET, I think it's really important to evaluate if that's something you actually need, because ABET's kind of a big commitment in terms of the course load. So I know it's kind of hard to visualize if you're like a first year or a sophomore, but looking at sort of the jobs that you want to work on later in life, and determine if those require ABET degrees is really important, because you can't go in a time machine and go back and get your ABET degree. That's not, so in my field, it was important to be ABET qualified because I'm working on public projects and public infrastructure. So there needs to be some sort of qualification test, which is why I started leaning more into ABET. And I also didn't really have an interest in computers, and only just wanted basic coding experience. But that's also to say that if you go into ABET, you have to take so many electives. So if you want to take EECS electives, there's lots of opportunity for that too. So it depends on what you're interested in and what your goals are later on in life.
Great, thank you, Taylor. Anyone else have another response? Well, if not, we can head over to the second question. I think, EE or EECS, at the end of the day, we both know that they share one thing, the classes. They're equally tough. And so I wanted to ask if you guys have any tips, tricks, or ways that you found were really helpful in managing your time for your courses.
I think for me, oh, sorry.
No, sorry, I just wanted to add here, like just in terms of just not time management, if you guys can give a perspective on stress management, because this is way more important nowadays. I mean, this batch has gone through, I mean, especially the panelists we have, they've gone through the COVID pandemic year, things are getting back to normal. And I'm sure you guys will come out like at the top of the stress management schedule. So if you can give in terms of time stress management, that will help the juniors to kind of navigate their life at Yale while they are pursuing a degree, right? So I think that would be also useful.
Sure. Yeah, and I actually a good chunk of my electrical engineering and computer science classes I took were during the pandemic, when all the classes were remote and stuff. So definitely not the most ideal situation to be learning such difficult topics. But I do think one of the things that helped out a lot was getting to know the other people in my class. Because the class sizes are going to be fairly small, especially when you get up higher into like the electives, knowing the people in your class can be a really good help for multiple reasons. One, it's like really nice to just know people in the class. It feels like you come in with friends. It feels like you have people that you can ask questions with and depend on. And then also just like, even just with help with homework, help with projects. Maybe you might have someone you get along with really well, and they might be an ideal partner for you to work on projects together. It definitely does make it a lot more fun. I think that's one thing that is maybe an advantage of EE at Yale specifically, because it's a little bit smaller. You definitely have the opportunity to get to know practically almost all the people graduating in your major if you so choose. And that can definitely be a huge advantage to just being able to relate with them on difficult assignments. It might help a little bit with like relating with stress or with the workload, and then being able to bounce ideas off each other and just kind of, I guess, in the cheesy way, being there for each other to some degree definitely can be very helpful. And so that's, I think for me, that's probably been one of the biggest things, is just getting to know the other people that are studying the same thing as you. You get to learn a lot through them, and hopefully you get to teach them along the way as well.
Oh, sorry. I'll just, so one thing that I would suggest is this is not entirely a time management or stress management technique, but it can help. But communicating with your professors or with your dean, that was something that was really important for me personally during the pandemic. I stayed at home for a semester due to a family illness, and I'm from a low income background, so my house is not well suited for like advanced engineering classes. I was taking like advanced physics classes with like no internet at my house. So it was a very stressful time. And I found that being upfront with your professors as soon as possible, even emailing them at the beginning of the semester and be like, hello, I foresee this class being very difficult for me. I struggled in this class in the past. And the EE professors especially are very accommodating, and they're very kind. And that has helped me immensely starting year one, but especially during the pandemic, is just being honest and asking for help when you need it. And that like helped so much with my stress and also my workload and a lot of like pinches.
If I could add on to what Taylor and Daniel have said so far, it would be to, and this can be a little bit difficult during a virtual year, I recognize that, but going to office hours, attending offices early in the semester, like first week, then the second week, just making a habit of going to office hours is really important. You start to really, not only is it a good place for you to ask questions, but you start to build a rapport with your professor. And that just really enriches the classroom learning experience. It's easier for you to learn. You're more comfortable asking questions in class. So, and that can also actually be an avenue for you to explore new ideas that you could have, or learn about new fields, such as wherever your professor's research background lies. So those are just really good experience that I highly recommend that you guys take advantage of during the school year. Now, in terms of stress management and the pandemic management, I think that setting limits for yourself is very important. in the sense that like trying to, it's okay, like we're people. We're not machines, and we need time to take care of ourselves. So I can share just a little bit about what I do. I work a lot during the week, and yes, I work a lot during the weekend, but Friday late afternoons and nights, as well as Saturday nights, off limits. I do not work. You will not find me in a meeting. I will not be in a library. Okay. Of course, there are exceptions like during crunch time, like final season or midterms, right? Sometimes you have to do that. You have to put in those hours. But understanding that, setting limits in your schedule for yourself, taking out time to just be with yourself, be with your friends is important. That can really promote mental health in a positive way. And it actually allows you to keep going. You come back into the next week refreshed, ready to learn, ready to work. And so that's just a tip that I have that I really think is quite helpful.
Thank you, Daniel. That's a great response. Does anyone else have anything to add? If not, we can, before we wrap up and head to Q&A, I just have a quick question that I would love for everyone in the panel to answer really quickly. I know you guys touched upon your immediate career plans, what you're doing in a year or two, but where do you see yourself in the long term? Where do you want to see yourself in 10 years?
I can tackle that one. I can get it started. In 10 years, hopefully, this is being recorded. It's a little bit of a time capsule moment here for us all. But I hope to be running my own social entrepreneurship venture in either India or Brazil. I'm Brazilian American, and I have had experience with the Indian culture and subcontinent. So I hope to be designing medical diagnostic devices for low to middle income and base of pyramid communities in those countries. That's partially why I'm going to go pursue an MBA over at Yale SOM, so that I can build up my managerial and business skills in order to really take my entrepreneurial endeavors to the next level. So I'd love to talk more about that if that's anybody's interest.
Anyone want to go?
Yeah, sure, I'll go real quick. I know for me, I'm not that inspired by like commercial products, so I don't really want to be designing a better toaster or anything. So I'd really like to be working at kind of the cutting edge of science and technology, and turning lab science that has just come out in the past year and trying to turn that into something that can make a positive impact on the world. So intersection of engineering and research, hopefully.
I can go next. I'm sort of reiterating what I said earlier, but I would like to be maybe not even like working directly in Lebanon, but like working in America or Lebanon, like with some company that helps with like sustainable energy over there, because I have a lot of family over there, and electricity is like very scarce. They get it for like 2 hours, 1 hour a day. And so I think my goal in the long term is to like help people in Lebanon, and then sort of like expand outward from there, obtain electricity and energy in a way that they don't have to depend on like whatever political, socioeconomic factors are like going on around them. So yeah.
I want to be involved in kind of big decision making regarding like this transition into green energy and carbon neutrality. So I hopefully will get like an MBA or a law degree and then go work in like upper management as a utility company, kind of being a very well-rounded engineer with all of this background and hopefully making really good decisions that will give people their energy and their electricity for the day. And then maybe hopefully later on down the line, if I retire or just get tired of, working a high life corporate job or something like that, becoming like a community college professor or like working to promote education for low income communities. So who knows what'll happen, but that's what
I think for me, I've always been fascinated by space exploration and aerospace, as well as space itself. I think the area itself gives a lot of opportunities to work on, like, let's say, for example, like the fastest planes or the biggest rockets or the farthest probes. These really, really cool ideas, these very inspiring ideas of applying electrical engineering that I think can make the job just a lot more fun. I think I would love to be able to, as Will said, be helping out on more of like the new research and development side, actually just like coming up with new ideas to approach new problems. And I don't know necessarily if that will be at one specific place or if I'll be moving around. Although the plan for now is to stick with NASA. I mean, no one really knows what might happen in 10 years, even just in 1 year. So definitely keeping an open mind, but my overall goal is to definitely contribute as much as I can to those big projects.
Sounds great. Some really great responses. Best of luck to everyone in your future endeavors. Can't wait to see everyone in 10 years. Maybe you can all come back. We can have the 10th edition of Life at EE, no pressure. Now we're gonna go to the Q&A. Taylor, there was a question addressed to you. It's about your experience with study abroad. Can you talk more about how you found an engineering related study abroad program? Because the person asking the question noted that a lot of the study abroad programs tend to be more humanities related. So how was your program and what was your experience like?
Yes, I'm so excited to talk about this because I wish more engineers studied abroad, because I don't feel like a lot of people realize that they can do that. And I'm an ABET major, so I'm still surprised that like it worked out, but like very clearly the system is in place to allow anybody to study abroad. So I studied abroad for a whole semester in Ireland, and basically I applied to a university to study there. I didn't apply to like a specific program. So I know there's some programs that are like, oh, like study music at this university, or study like, I don't know, what other things at other universities that aren't STEM. But you can apply to the actual school and kind of create your own curriculum. So I had the limitation of being an English speaker. So I decided on Ireland. And I actually got ahead in my major by studying abroad. It didn't put me back at all. I was able to take 5 engineering classes that counted towards the ABET degree, and I just went through the classes, picked all the ones that were interesting to me, and then I approached the US and I was like, would this transfer in for this requirement, such as like would this transfer in as for like linear algebra, and would this be an elective, and blah blah blah. And it was a very easy, very smooth process. It was very rewarding. I was able to do research. It was a very diverse experience. I'm really sad it got cut short because of the pandemic. But like the 2 months that I had there were really important for me. So if you have any questions about studying abroad as an EE major, it's definitely possible, and you can feel free to reach out to me if you need any extra advice. But please do it if you're considering it.
Sounds great. Thank you, Taylor. There was another question asked to Daniel. Some person wanted you to talk more about your experience with the interface between EE and biotech/medical devices. Can you talk more about the labs that you were working for and how you feel EE trained you for this field? And also if you plan on continuing to follow your interest in medical devices.
Yeah, thanks for the question. So I'll kind of go backwards, I guess, with that. Yes, I do plan on pursuing my interest in the medical device industry. That'll be quite interesting as an MBA student, I think. So it'll involve certainly a lot of reading. One thing that I don't think we've any of the panelists have mentioned this yet, but look for professional organizations, such as, for example, IEEE. As an electrical engineering student here at Yale, I highly recommend that you take advantage of the discounted student rates for memberships, for various council subscriptions, and you can actually subscribe to magazines, you can subscribe to journals, you have access to educational videos. So I highly recommend that you take advantage of that resource, because that's one way that I plan on remaining engaged with the biomedical devices field. There's actually an IEEE transactions journal on specifically this subject, where research groups can actually publish recent advances that they've made, and I can just read about it and stay more up to date. So that's one way that I feel like I'll be remaining current, up to date with that. Now, as for the lab, I was working in a Reed lab with Professor Mark Reed, who unfortunately passed last year. I don't think that I'm not sure actually how long the lab will remain functional. We're currently transitioning, I think, into the Yale School of Medicine. So whoever asked this question, if you're interested, you can send me a message, a direct message here in the chat if possible. I don't know if you have the capability to, and then we could just talk about it more in detail there. In terms of the interface between EE and BME and whether or not, which one was better for me when I started working with medical devices, I would say it kind of depends on the type of medical device. I more or less stumbled into this field. I was very deep into renewable energy. As I mentioned, I worked for GE for 2 summers, and then suddenly I pivoted at a 180. I'm like, okay, I want to do healthcare. So naturally, because of my electronics background, I've been very exposed to the bioelectronic space. So that's really, diagnostics, monitoring, all sorts of things, predictive models, a little bit of computer vision with Professor Panda's class on neural networks. So in that sense, EE has prepared me tremendously for it. If I were to, for example, say that instead I wanted to work with biomechanics, so designing some form of a prosthetic, I could maybe help with the controls circuitry that would go into an electronic prosthetic, but actually designing the mechanical, aspect of one, that's not really my forte. I wouldn't really be able to actually do that. So, it kind of depends on where your interests lie within the medical device field. In terms of EE over BME, speaking again more specifically towards the bioelectronics industry, I would recommend EE over BME, because EE will train you to look at the circuitry, will train you to think in that black box approach that I mentioned earlier during the panel discussions, where you don't really need to know all of the inner details of something. You just need to know how it responds to different inputs and what outputs you can get. So you can use this design methodology within BME, within medical devices, to really design these tools. Whereas in BME, from what I've gotten from speaking with my friends who are in the major, they focus a lot on the biological side of things. And this, now what I'm about to say, goes for anyone here, regardless of your interest. While you're doing engineering at Yale, learn how to learn. That should be a massive priority for you. Learn how to think like an engineer and learn how to learn, because once you get that skill down, you can go into any field you want. That's a big secret. So for example, with me and transitioning from EE, electronic circuitry, hardcore stuff, into like a wet lab, I don't really know much about microcellular biology, but I learned how to learn. I learned my style of learning so that I can quickly pick up the concepts and then link them to my previous knowledge in EE and see, okay, how can I work with this? What are the variables involved, right? So that getting that skill, using your time here at Yale wisely, it can be very helpful with that. Let's see, I'm making sure I touched all the points in the question. I think I did. I spoke a lot, but please, if you're interested, just send me a message and we can talk.
Thank you, Daniel. That was an amazing response. And talking about going into any field as an engineer, someone in the Q&A asked, without knowing for certain what industry they're going into in the future, should they prioritize an ABET electrical engineering degree or the non-ABET degree with a set of other non-EE electives? The question is open to anyone.
Kind of what I would say is, one of the things I really love about how Yale's designed the EE program is you can really punt that decision down the road and just take your first couple of years and decide, like, figure out who you are, figure out what you're interested in. All of the intro courses for, EE ABET, EE non-ABET, EECS, they're all the same. So just if you know you have some interest in engineering and electrical engineering, take the intro classes, take whatever electives you want, take your distributionals, and then you can, you can decide like as a junior or as a late sophomore whether you want to go all the way to ABET or take some CS classes. Now let's say you are at that point right now and you're wondering, what you should do. I mean, I'll go back to what I said earlier. All of the EE professors are very accessible. Drop them an email or just go visit their office and say, hey, I'm not really sure, whether I should do this, this level of EE or this type of EE. What do you think? And I'm sure Professor Panda, she's on the call, she could talk. Professor Manohar joined, and he's the DOS for EECS. The engineering professors here are usually very accessible. But yeah, the biggest thing is don't decide as a first year. Don't even decide as a sophomore if you're unsure. Like, you've got a lot of time. The start is the same.
Does anyone else have another answer? Awesome. If that's it. Thank you all. Some very amazing responses. Thank you for coming here. I think that's it for the Q&A. Without further ado, I'll hand it off to Professor Panda so she can end with some closing remarks.
Okay, thank you so much, guys. This is so interesting, so interactive. Again, the panelists, the moderators, they did a tremendous job. And I hope we got to all the questions that the audience had asked. And hopefully the panelists have been very nice enough to kind of, interact with them. Please email them. You guys all have their email IDs from our website. But thank you so much. I think this has been really interactive. We hope to hold such versions even in the later semesters. I just want to ask, introduce you to Professor Rajat Manohar. Most of you would have met him, and he's been kind enough to join the call here. Thanks, Rajat, for joining in. Maybe Rajat can say a few things to the seniors as well as the juniors here who are here on the call.
Hi, everyone. I'm not sure. I don't have much to say, frankly. Sorry, I was late. It turned out I had a conflict at something else at the same time. Of course, my Mac is not really cooperating. As you can see, video doesn't work. It turns out like a bunch of the function keys also have stopped working. So I don't know how long this is going to work for. But anyway, so I just want to say thanks everyone for doing this. This is great, and thanks Priya for working with the students to make this happen. Feel free to email me if you have any questions. The door is open. So I'll just leave it at that.
Thank you so much, Rajat. Yes, and again, my closing remark to all is I think the panelists mentioned that, explore while you're here at Yale. And as I said, my door, all the EE professors' doors are always open to you. Even the CS professors' doors are open to you. So please let us know. Communication is going to be very, very important as you move through your trajectory. So thank you again. Before we end the panel, if it's okay, can everybody, all the participants, the panelists, everybody turn on the video, and maybe we can take a small photo, just because it is sort of our first seminar. Maybe Russell, if you can do that, it'll be great. I remember Daniel did that in one of his South Asia panels. So I remember Daniel doing that. So I'm going to steal that idea from you, Daniel. Okay. Everybody, how do you do this? I have no idea. Do you go into
I can just take a screenshot, I guess.
Great. That would be great.
Okay. 3, 2. Oh, wait, sorry. I need to exit this chat. 3, 2, 1. Okay, awesome.
Great. Thank you so much, everyone. And hopefully the next time I'm going to hopefully organize this in person. Coffee, free food, as Daniel has suggested. That's the best way to get more students, and that's how it's going to be next. So thank you all. Thank you, Russell. Thank you, Daniel. And thank you, Yazan, for doing this. Thank you very much.
Thank you.
Thank you, Professor. Thank you.
Good night, everyone.
Thanks, everyone.
Hey, guys. I think it was good. I think, maybe.